Hello and welcome to SudoKanard. We have a look at this consecutive pair Sudoku by Snyder. It was featured on this Sudoku Grand Prix, which was round 8, and 8 can be seen in many places in this grid. Those patterns of white dots and the given 8s, obviously. So the special rule of consecutive pairs is that whenever you have a white dot between two cells, it means that the corresponding digits must be consecutive. But very importantly, the lack of a symbol of a white dot between two cells means nothing. The digits could very well be consecutive, they could very well be non-consecutive. That gives no additional information. If you like this variant, you can find tons of such puzzles on Grandmaster Puzzles, the website that was founded by Snyder. And you can also find lots of consecutive pair Sudoku on Akash Durrani's website. He's a specialist of this variant. So let's begin. We have 7 and 9 surrounding 8. We have 2 and 4 surrounding 3. 3 is here, so there must be a 3 in one of those positions. And there are a few things to note. One of them is that here we have dominoes with consecutive pairs. Here we also have dominoes of consecutive pairs. And what's interesting is that a domino contains an even digit and an odd digit. So here we have 3 even digits. That's the 4th one. So this column has all of its even digits in here. So this one must be odd, and it can only be 1 or 9. The same happens here. 3 even digits here, a 4th one here. So this must be odd, and it's also 1 or 9. And that's interesting because we get a 1-9 pair here. This can only be 2 or 6, and those are from 2, 3, and 6. Something similar is happening in this column. We have 3 even digits here. This is also even, so this one is odd. On this column, we have 3 even digits here and the 4th one here, so this one must be odd. Not sure this will really be useful, actually, but I thought I mentioned this. On this row, we have 2 even digits here, 2 even digits here, so this one is odd, but that's 5 values, so I won't pencil like that. The same happens here, the same happens here. So right from the beginning, we know that we have 3 odd digits here. And in particular, 8 must be somewhere around there, and 8 must be somewhere in here. Not sure that will be so useful there again. That's just some interesting stuff, I think. Now, let's ponder where 8 goes in this column. 8 won't go here, so 8 will be here. And 8 will be surrounded by 7 or 9. And actually, it won't be next to a 9, because if I try to put 8 and 9 here, then what goes next to the 9 here or there, well, I won't repeat the 8. So this is actually a 7-8 pair, and the 7 will be accompanied by a 6 here, the 8 will be accompanied with a 9, so that's a 6-9 pair, which puts the 2 in here. And now it resolves the 7-9 pair on top. Puts a 1 in here and a 9 there. So that's nice. And in this column, I still need a 2 somewhere. It could be here with a 3 and a 1 or 3 here. Could be here with a 3. Well, I have no strong hint as to what goes in here. On this row, I still need 5, 6, and 9. This will never be 9 because it would require an 8 here, which would break. So that's a 5 or 6, and there's a 9 somewhere here. So 9 does appear somewhere here. So it's either here or here. Oh, sorry about that. I typed 8 instead of 9. There again. Oh, what am I doing? All right. And that's interesting because 9 here would force an 8 there, which doesn't work. So 9 is actually here with 8 and 7. And I still need a 1 somewhere in there. 1 next to a 2. So 1 here would put a 2 here. That doesn't work. So that's a 1, that's a 2. And only 1 works here. That's now a 4 and a 2. And this is the 4, the 5 or 6 counterpart of this digit here. This one does not appear up there. I still need to put an 8 and a 9 somewhere in this column. And 9 will be next to the 8 on one of the dominoes. It can only be here. 4 is here with a 5. So 7 with a 5, I said, so that's a 7. 4 consecutive digits here. What we can ask, well, actually, we know that 7 is somewhere in here. And it won't be followed by an 8, so it will be 7, it can be 7, 6 with a 5 here. And it will resolve that nicely. But it could also be 7, 6, 5, 4. No, it wouldn't. If I try to put 7, 6, 5, and 4 in here, then there's no value for that. So I think this proves that 7 is necessarily here. And that's a 6 and that's a 5. So 4 and 5. That's not 5, that's 1 or 3. And those are from 1, 3, and 4. But considering those are 4 consecutive digits, those must have a distance of 3. So they are 1 and 4. And we get 2 and 3 in between. That works. This 6, 7 resolves all of that. 8 is not here. 8 is next to the digit here that is a 9. Up there, that's now 3 or 4. Together with, well, 3 would be with a 4. 4 wouldn't work. 3 and 4. That's a 4, 5 there. I still need a 7 on this column. It can only be here, and that's a 1. Which resolves, well, that must be a 6 now, and a 5. Here that's a 1, 2 pair. Here that's a 3, 4 pair. This 1 and 2 resolve that. 1. This can only be a 4. And it also resolves that. This now can only be a 2 with a 1. In this box, 1 goes here. Here I need a 2 and a 6. Here I need a 9 and a 3. So that's an 8, 7 pair. 8 here, 7 there. That's a 9, that's an 8. Here 3 and 5. Here 6 and 9. I will find them later, I think. Here that can't be an 8 anymore. This is from 5 and 6. Here I need a 4 and a 7. So how do I finish this? Oh, next to the 5, this should be consecutive, so that's a 6. 9 here, 6 there, 5 and 6, and finally a 9 in here. Nice, very well put together. I think I struggled more than that when I solved it during the round. I didn't find all the eliminations I found during this video. So there's a lot to explore. I focused a lot on those considerations about odd and even digits, but appears in hindsight to have been somewhat a waste of time. But there's so much you can explore in this Sudoku variation that it's not easy to aim for the right method right from the get-go. That's where you recognize the best solvers, of which I am not. Thanks for watching this video, and see you soon on SudoKanard.